HVAC 360, episode number 37, Net Zero Energy Buildings. Welcome back, everybody, to another episode of HVAC 360. I am your host and guide on this crazy journey, Matt Nelson. This week we got a very special episode for everybody. Net zero energy buildings. Obviously, it's a great topic of mine, but it is a special listener request coming all the way over from Poland. Yes, realize that when I say give me any suggestions, I mean give me any suggestions. So this is just proof that you are very connected to your host here. And if you do have a suggestion, just drop me a line, matt@buildingx.co. And this one comes, I'm not even going to try to pronounce his last name. If I was to say his first name in English, I'd say it's Michael. But if you're from Poland and your name starts with Michael or Mikal, or however I would say it with a Polish accent, which I don't have, so I'm going to stop there. Anyway, I dug around and I came across an expert in the field of net zero energy buildings. He comes to us by the way of the National Renewable Energy Labs. That's one of the 8 laboratories that's associated around the U.S., doing some good research work, but also kind of known in the circles as NREL. He is Paul Torcellini. And he is a principal engineer there, and he's authored a number of papers that go into net zero energy buildings and the like. So I appreciate Paul spending some time with us, and I know I'm going to thank him on the back end. So let's just cut to the interview. Here's Paul Torcellini with the National Renewable Energy Labs. Let's cut to the tape. All right, today we're talking with Paul Torcellini of the National Renewable Energy Laboratories, or NREL. He's a principal engineer there. How are you doing today, Paul?
Good. And yourself?
I'm managing. I got a little bit of head cold, but we'll get through that today. So, tell me a little bit about your background.
Okay, so I'm a mechanical engineer and have focused primarily in energy efficiency for buildings, and my thesis topics were related to that. I have almost 20 years of experience at NREL, managing a group of research engineers looking specifically at what it takes to create very low energy buildings.
Now, I guess you Google your name, and there's a whole bunch of papers that just pop up. How many papers have you contributed to over your career?
Oh, it's certainly in the order of several dozen papers, primarily related to case studies of low energy buildings, measuring actual performance of low energy buildings, and more recently, the concept of zero energy buildings and how to actually accomplish that in today's world.
Now, tell me a little bit about what NREL is. I mean, it's the national energy. You explain it.
Okay, so the National Renewable Energy Lab is one of several national labs that is owned by the U.S. Department of Energy, predominantly funded by them through the U.S. Congress. NREL has a very specific mission to look at energy efficiency and renewable energy. Not only do we do work in the buildings area, but transportation, biofuels, wind, photovoltaics, solar thermal. So there's quite a broad range of trying to address critical research issues to reduce energy impact.
Now, you talked about low energy buildings. I guess what was there a large difference? I mean, was there a shift in focus from going from low energy to zero energy, or what made that shift?
Not really. I think there's a lot of words that have been used to describe buildings that have less environmental and energy impact. people talk about high-performance buildings and green buildings, low energy. I think many years ago the term was more passive solar buildings. Whatever it is, they're really buildings that minimize their energy consumption, impact on the grid through better design, through better operations. Ultimately, the objective is not so much the name, but how do we really reduce the energy that goes through that meter. The zero energy term came about as probably a couple different pieces there. One is that it's a nice benchmark that people kind of gravitate to it because the implication is certainly that there is none or minimal impact on the grid. In reality, when we talk about zero energy buildings, most people use a definition that you're you're generating energy on site, using it in your own building, and anything that's extra you export to the grid. And then if during the year you need some of that energy, you can actually buy it back. And so over the course of the year, the balance is zero across the meter.
Now, I guess you've touched on an important point because there's been some discussion if you're at all involved in this topic about a site net zero building or a source net zero building. Can you explain the difference?
Sure. A lot of it has to do with how we define a boundary, and so backing up one step, one of the things about zero energy buildings is that zero is a real number, as opposed to a green building or a low energy building or high performance building. We can talk about those terms all day long, but there's no real definition that says it is or isn't. So a zero energy building creates a definition of zero. Now, the next question is, what is zero? How do you define the boundary? And what metrics do you use? And so when we talk about a site, really we're talking about the amount of energy that goes to and from that site through that meter, and that's where the boundary is. And it could be the building, it could be a campus, it could be a subdivision or small community that establishes that boundary to interact with and do that accounting. When we talk about source, we're really backing up that boundary to include inefficiencies at primarily the power plant and the distribution of that. But it also includes things like, the amount of energy to move natural gas to your site. We've even looked at issues where people have on-site wood chips and they want to look at it from a source point of view, and we include the transportation costs or energy to bring those wood chips to the site. It really is how you define the boundary. Now, on the other side of it, when push comes to shove and you actually have to measure something, you're not going to go out to the power plant and measure how much coal went into that power plant. But what you do is you look at your utility meter, which is site-based, and you use some kind of multiplying factor to try to get at the source impact of that. And there's a lot of discussion about how that multiplier is determined and whether it's valid or not. Ultimately, no matter what definition you use, it ultimately comes back to your building's boundary and trying to minimize your impact on the rest of the grid.
So, is one more important than the other? If you're thinking about building, a net zero building, does it matter?
It does to some extent. I can give you, some interesting examples of people trying to reduce their environmental footprint. One would be something like, I'm going to build my building in Seattle because the site-to-source conversion is better because they have a lot of hydro on that grid. The reality of it, though, is that if you build a building in Seattle, that hydro has been fully subscribed many years ago. And so all you're doing by building that building is actually increasing their footprint, and the chances are that incremental dispatch is coming from something like natural gas. So part of it is that sometimes, when you set a test and you set the boundaries of the test and people want to pass, sometimes people say, well, what is the most creative way I can use to pass that test? And, check it off that I've met that accomplishment. And that's what we see more in how people choose boundaries, not more that one's better or worse than another. So, in an ideal world, you'd say, well, I'm net zero site and I'm net zero source. You could even extend that further and say I'm net zero emissions, which is another metric that's used. And, you mentioned looking up some of our papers. We have papers that actually describe kind of the pluses and minuses of the different definitions. And in particular, when you choose one, over another, what games might you be playing with that? I've also seen some very funny ones, like people creating net zero electricity buildings. And in reality, what they're doing is they're buying a lot of natural gas, generating their own electricity, and then exporting electricity back to the grid. And they kind of ignore the natural gas piece of it. So people get creative, which is one of the reasons why we actually did some writing on what we consider to be a zero-energy building and why.
All right. So, when we talk about, at least in the United States, when we talk about, scope of how many buildings actually, are kind of, have this, name net zero building, I guess what's this kind of the scope? Are we talking about a lot of buildings? Are we talking in the tens? Are we talking in the thousands? I mean, what's the scope of this?
Well, we don't officially track it, but my feeling is it's probably kind of in the tens range, tens to towards 100. We do have a list of some buildings that we know are out there that are zero energy. And if you are very purist about that definition, people talk about having things like off-grid houses. Well, those aren't really zero because, according to the definition, quite often they're using propane or something for cooking or for emergency backup generation when they don't have enough photovoltaics. So those even don't qualify under a zero definition. But we do know, that there are definitely some out there, and we hear more and more every day about people either striving to do that or that they've accomplished that.
Now, is there a feeling that, there's any growth in this area? Is it more interest based?
Well, there's definitely growth. There's a segment of the population that I would call very early adopters that are interested in doing this and have made a commitment, usually as building owners, owner-occupied buildings, that this is something they want to do. And I would say, 10 years ago, I didn't hear of anybody doing something like this, or at least publicizing it. And I'd say today we're getting a lot of interest in the topic. A lot of people are realizing that it's not as expensive as they thought it might be, and that there are more and more examples. And the more examples you have out there, the more people that realize, oh, it's something I can have, it's something I can do. It's like any kind of technology adoption. If you said 30 years ago, how many people have cell phones? Well, the technology was out there, but people didn't have them. And then suddenly, almost overnight, in the last decade, suddenly everybody has one. And so, we are at the very early stages of this. And, obviously anything you can do to accelerate that helps. And part of that is just knowledge and people learning about the concept and saying, oh, yes, that's something that I want. That's something I'm willing to go out and purchase.
Right. Now, I know that if you look at ASHRAE Standard 189 for the high-performance buildings, their ultimate goal is to kind of drive it down into a net zero design manual, in essence.
Yes, well, and it's not really a design manual, but it's really a standard to say that you've either met that or not, just like you've either accomplished a zero energy or not according to, a definition. But it's showing the interest in the direction. Even ASHRAE 90.1, the newest version 2010, is substantially less energy than the previous version, 2007. And there's several organizations. You've got Architecture 2030, California Energy Commission. ASHRAE has made statements. All these organizations have made statements that this is the direction they want to head. And many of these, the target numbers I'm seeing is somewhere in the 2030 time frame to actually, have this be a very routine thing.
Right. Now, I mean, as far as, I guess globally, when we take a look at this, are there areas around the world that may be ahead of the U.S. or that may have been, thinking about it differently or acting upon it differently?
That's a difficult question because, there's different policies, there's even different needs and different regulations in different parts of the world. Certainly, the International Energy Agency in particular, a couple of the groups, including the Solar Heating and Cooling Group, have task forces looking at this and what research is needed and helping to accomplish some of that research. Task 40 from the Solar Heating and Cooling Program, International Energy Agency, is one such program that's doing that. And it probably has 20 or so countries involved in collaborating together, looking at definitions, looking at what case studies are out there to use as examples, basically to help move this forward. I'm not as familiar with some of the European Union directives, but I believe they also have some directives that are heading towards zero energy in the long term.
Okay. So I guess the big question is, okay, when you think about a net zero building, what are some of the technologies being employed?
So it ranges all across the board. The first, let's divide it into kind of big families first. The biggest thing you need to do is reduce the energy load, and unless you can get that load down 50 to 70% from kind of the current codes, what current practices today, it doesn't make sense to put the renewable energy generation on the building. Now, you can still do it, but if you're trying to do it from an economic point of view, you need to get to that, say, 50% savings first, and then the remaining load can be generated. Most people are using photovoltaic technology to do that generation. Quite often people say, well, I can make my building green and I'll put a bunch of solar panels on it and be done. But really that's missing the point here. It's really to save that energy first. There are many technologies that can be used in broad families. Usually we classify it as first, deal with the lighting load. Most buildings in the United States could be or could have been day lit, that is using the sunlight to offset electric lighting loads. In commercial buildings, that's usually your biggest impact. That also reduces your cooling load, allows you to downsize that equipment. The next piece is usually the plug loads, what we call plug-in process loads, or miscellaneous electric loads. It continues to increase in buildings. But that is something that the owner can manage. One of the things that we did at NREL was we went through and inventoried our plug loads and really started looking at what we were doing from an energy consumption point of view with those loads. And we reduced them in half. We started moving to all laptops, and the flat screens are pretty well in the marketplace today. But even things looking like we had fax machines all over the place. And there's a technology, and I think sometimes what happens is once something gets plugged in, it never gets unplugged.
Like taxes.
And so we basically eliminated all of our fax machines. We eliminated a huge fraction of our printers. We went to 3-in-1 document processing devices that take care of all of that. We're scanning a lot more. Email has certainly changed that dynamic. But we reduced our plug loads 50%. We also looked at how we were managing our data center. And this was all part of us procuring what we believe is the world's largest zero-energy building now. But we had to reduce our plug loads in half in order to even think about being able to procure such a building. Once we did that, and I already mentioned the daylighting, we looked at, in our case, natural ventilation, operable windows in the building. The loads became so low because of reducing the plug loads and the lighting loads that we went to all hydronic-based heating and cooling, basically in the slabs, in the concrete slabs of the building. We condition the outside air separately, so we can regulate its humidity and bring it in as it's needed in the building instead of just blowing a lot of air in order to keep the space heated and cooled and then ventilated. So we really looked at what all those loads and all those pieces were. And at the end of the day, we created a building that uses half the energy of a conventional code-compliant building. And then we designed the roof such that we could put the photovoltaics on the roof as well as the parking garage next to the building. And as a complex, that complex is now targeted for zero energy. We're not quite there yet because the photovoltaics on the garage isn't going to come online for another couple of months. It kind of was delayed, or it was after the building was built by about 2 years, just in our construction sequencing.
Now, I mean, I guess, it's interesting to kind of go through, okay, first you have to reduce the load in the building. I mean, it's always a kind of a mentality that I've seen that, people try to say, okay, well, we need more efficient equipment, rather than, looking at how we're consuming now and what we can do to reduce that, kind of just a way of doing business, so to speak. Now, as far as, just in, maybe in general, I don't know if you've researched this at all, but I mean, if you just take a look at, the way people work, just different habits. I mean, if somebody was to do, no upgrades at all to their equipment, but taught people to be more responsible, or to say, hey, you know what, maybe we can deal with a wider temperature range. I mean, typically, doing something like that. I mean, is there any research about savings in that vein?
Sure. So the occupant has a big role and responsibility here, for sure. But we don't want them to be uncomfortable. There's a lot of layers to that question that you just asked. Sometimes, especially when we're looking at retrofit of buildings, which I think is, a lot of your comment was related to, you've got to be somewhat careful. People complain that a lot of big office buildings in particular are too cold. Well, that's actually a energy efficiency measure, because in order to get the humidity out of the air in these old traditional HVAC systems, you have to cool down the air to get the humidity out and condense it out. Most of those buildings then would require that you reheated the building up to a comfortable temperature. Well, that takes a lot of energy. You hear about people that say, oh yeah, we're running our boilers in the summertime to keep the building comfortable. Well, a lot of buildings, as an energy efficiency measure, have backed off on that reheat, and as a result, the buildings are cooler. But that's a condition of how that heating and cooling system was set up. There's still a lot of what we call constant air volume systems out there, and in reality, if you reduce the plug loads in your building, the constant air volume building is going to make up that heating load with additional, usually electric resistance heating, and you get no energy savings. So you have to look at what kind of system type you have and sometimes just change that system out fundamentally. We had the option in our building that we were doing new construction, and by doing the radiant surfaces, we actually could create a very comfortable environment for the people without necessarily heating and cooling the air in that building. And so that does give us a whole lot more flexibility and range in what the physical temperature is versus what the temperature the occupant senses is, and then those can be very different.
So, getting back to the equipment, is there anything as far as technology goes that is gonna help making net zero buildings easier in the future?
Sure. So the more technologies that are out there to become more efficient, the more options people have to achieve the same energy goal. And so, you could save a BTU many different ways. So, if you are fundamentally going to use a rooftop unit, and there are now coming onto the marketplace some rooftop units that have much better part load curves, and so they can get an IEER rating of up over 18. That's 50% better than equipment that was out just a few years ago. And so that obviously has an impact, and that those kinds of things get you closer to zero. But on the other side of it, you say, if I can design the envelope so well and I can get my cooling load down with day lighting, that maybe I don't need those rooftop units or as many of them, the best piece of equipment is one that's not running at all.
Right.
And that needs to be a consideration or doesn't run much. I can give you a good example of this. People often are very critical of electric resistance heating. And we actually had an example of this in our building where we use electric resistance heating in our bathrooms to heat hot water for the sinks at the point of use. And that was, the alternative would have been to have natural gas as a central boiler to heat that hot water, and then circulator pumps to run that hot water back and forth to all the sinks. Well, as we did the analysis, it actually used less energy to heat that water at that point of use, only when people turn on the sink, than it is to even run the circulator pumps, let alone run the boiler that initially had to heat that water.
Wow.
And so there's an example where if you kind of look at it as a system, the, quote, energy inefficient piece of equipment, i.e. the electric resistance heater, and people consider it inefficient more because it's electricity and you've got that site-to-source conversion, that somewhere, either coal or natural gas, only 1 out of 3 units of that energy is ever going to reach the building. The rest of it's kind of thrown away in transmission and energy efficiency at the power plant just because of natural cycles. But in our case, we found that it was a better solution to do that because they don't run much, and they were able to better manage that load. And so you have to kind of look at it and holistically, and we kind of did that even at the whole building level, saying we want this building to perform to a set energy goal. We put out a challenge and actually procured the design build contractor to do that, and then they had to achieve that with that fixed price. That allowed them to bring their creativity to the problem to achieve the goal at a fixed price.
Right. Wow. Now, obviously there's a lot of, you said inefficiencies with the transmission of electricity. There's, bound to be a lot more inefficiencies out there. I guess the one thing that really fascinates me and are like batteries. If you're able to store energy on site, so you don't have to kind of give it back to the grid and then buy it again, is battery technology improving? Is that becoming more and more developed?
Battery technology is certainly improving. And a lot of that's being driven by the hybrid vehicle industry because they've got a situation. Well, and even small electronics. Where they have a need to have something remote, they have the power management, they want good, weight ratios in there. So a lot of that research is being done at that, in that specific area. It will move over to the buildings area. One of the things to think about, though, is that storage takes on many forms. I already talked about us having laptops, which is a very interesting mechanism. But, when you have a building that has 800 laptops in it, there's a significant amount of battery storage in all those laptops that, if you really wanted to, you could better utilize as part of the whole dynamic of your system. There's other ways of getting, effective capacity that way. We've got, because we're doing our radiant heating and cooling in the floors, that concrete mass acts as a thermal battery. In fact, just to kind of put in perspective, between that and reducing our loads, our envelope loads, good insulation, we talked about the lighting and the plug loads and things, we only have about 20% of the capacity, cooling capacity of a traditional office building built in the Denver metropolitan area. Oh. And that, had other implications, but that's because of this whole integrated piece. It really changed, the thinking of how to design the whole piece, and that storage was just inherent in those building envelopes. We just exploited it.
Now,
there's some things that. Oh, go ahead.
No, go ahead.
There's some other storage technologies which are people are starting to think about. Ice is one where you can either make ice at night, or if you've got excess solar capacity, you could turn that into ice. One of the things about peak demand on buildings is that it does not occur when the sun is brightest. It usually occurs 4 or 5 hours after that, kind of in that 4 to 5 o'clock in the afternoon range. Mm-hmm. And quite often, if you can store enough ice, you have all this photovoltaics in a zero-energy building, and you can use it to make ice in the morning, you could even melt it that afternoon to provide that cooling load and help, ramp through that. Ice is a very efficient storage mechanism because you basically get back close to the same amount of energy out as you put in. Where battery technology, you're only going to get about 80% out compared to what you put into that. Mm.
Now, if somebody's looking at making a net zero building, does it matter the location? I mean, is there adaptations for each area? I mean, if you're in Florida, it's hot and humid, or whether or not you're in northern Montana, where it might be cold and dry. What is there kind of just a building type for everybody, or?
There is not, which I think has always been one of the challenges. Much like there should not be an HVAC system for everybody, but unfortunately we tend to deliver the same system to everybody. But the solutions change, and there are definitely areas that are easier to achieve zero energy than others. I mean, if you're building a building, on the coastline in California, a very temperate climate, temperature doesn't change much. Really all you have to do is, if you have a well-insulated building, you don't need much of a heating and cooling system, and all you have to do is meet the electrical load piece. If you build that building in Miami, you might have a huge abundance of sunlight that you can convert into your daylight and use the photovoltaics for generation. But you also need a lot of energy just to dehumidify that building and make it, comfortable, in the summertime. Montana's the opposite end. You're going to have less solar gain available, and you have a much larger heating load. But that usually gives you some opportunities on the passive heating side. The solutions definitely vary. I think the real message here is that if you're a building owner and you're spending real dollars on this, figure out how many dollars you want to spend on your building, and then go out and hire a design-build team to deliver that product as a single product that achieves all of your goals, and competitively find the group of people that is going to get you that product.
Okay. Well, let's
and they will come up with the design solutions, to meet the need in that environment. I often like historical architecture, and partly if you look at a building that was built before, say, 1930, and especially before 1900, energy wasn't readily available. And so quite often the architecture had to follow, the climatic sensitivities in order to keep that building comfortable and best meet its occupants' needs. That's why in the Southwest we tend to have a lot of adobe construction. A lot of the earlier factories that were done in the Northeast part, New England area, are long, thin bays with lots of windows because they wanted to get the daylighting and the cross ventilation in. So sometimes you just have to look back at how we did buildings 100 years ago, because they had to design those things in. And a lot of what we're seeing in today's low-energy buildings are just adapting to those, somewhat older technologies, older ways of thinking.
Right, because, essentially you get ideally you'd love kind of, here are the things that are working in this region, based on our climate, and the fact that, we don't necessarily have to have zero-energy buildings built to know that. You can go back in history and find, okay, here's kind of what worked in our region. Let's tweak that, update it, but keep some of the thought processes that were there.
Absolutely.
Great. Now, when we talk about net zero engineering, you hire the design builder, to do this, and obviously, if there are not that many buildings, that has to be somebody pretty special. Or maybe not so special, but they'd have to have some basic set of skills. What do you think is going to be the keys of success engineering-wise, for designing net zero buildings?
I think that you have to not look at how you did it yesterday if you've never done this before. Really, it's about thinking out of the box, thinking about, as an engineer, go back to engineering school and say, what are some fundamental concepts? How do I really think about how energy is flowing, and not just, well, I'm going to install the same rooftop unit I did last week because it worked last week, it's going to work this week. And so up front, it takes some creative thinking, and it takes some brainstorming and a little bit out of the box. We talked about looking at some things historically. I'm not sure that, other than the creativity and the willingness to kind of trust your calculations and to think out of the box, I would say are the biggest skills that we need to kind of remind engineers that most of them have, and a lot of them haven't probably exercised them as much of late.
So use those long-lost muscles is what you're saying.
Absolutely. I think in a lot of cases, especially people that have been in the industry a long time, there was a lot of interest in this in the late 70s, early 80s, and it kind of disappeared a little bit, at least from the forefront. And there were schools that were teaching some of that then, and some of it is just dusting that off again, and even just looking around and saying, what else is out there? How can I help the owner and challenge him to think differently? Things like, if I'm an HVAC engineer, and the other part is, let's get out of our silos, right? If I'm designing a heating and cooling system, and I look at that building and say, hey, I could drop the size of that system by 30 or 40% if the lighting designer would put in daylighting sensors and actually get those lights to turn off, right?
Right.
I might be able to save a certain percentage if I can, get the architect not to create a glass box that doesn't have any solar load management. What we can't be on the engineering side is the tail end here, right? We've got to proactively think up front on how can the architecture and the building reflect the energy of it. It's a team process. But on the other side, the architect really rarely will get blamed for having a low-energy building. It's always the engineer, because he was the one that put in the heating and cooling system that's running too much and using all the energy, right?
Right.
So, it's really, as an engineer, I think you have to be able to push it. So when we did our building and did the procurement, interestingly, the contractor, one of the things that they did was they hired very early on an energy consultant that ran the modeling, and they were the engineering firm, to make sure that those decisions would work in parallel with the architecture as well as the construction philosophy. Because that's the other piece, is that quite often architects and engineers design these buildings, and there might be something out of the box. I mean, we've talked about the radiant heating and cooling tubing, and most contractors may look at that and say, well, I've never done one of those before. I'm willing to do it, but I'm going to double or triple the price.
Right.
Right, and that will discourage them from doing something different. Well, the contractor has to be willing too. And in this case, because the contractor, the engineer, and architect were all on board, they started brainstorming and said, well, the way we're going to get there is to use this radiant floor system or radiant slab system, and made a challenge to the mechanical subcontractor, saying, well, how are we going to get this installed at a competitive price with the normal sheet metal ductwork and air-based systems? And they all scratched their heads and found a way to implement that process. And partly because they were all in the boat together. They were all responsible for achieving the same goal. It wasn't piecemealed like a lot of design and construction is done now.
So do you think that it's critical to, I mean, obviously you have to have, obviously integrated design is being thrown around there quite a bit in the industry, but do you really think that it has to be, a whole team kind of event with getting the contractor on board? I mean, is this really the only way that you can successfully attain a net zero building?
I don't think it's the only way. I think what we have found is that given the small marketplace, that it is probably the easiest way, that it fosters the communication, it makes sure that everybody is on the same page, heading in the same direction, because you also have a whole quality piece that has to go with it. I mean, I can't tell you how many job sites I've been on where the plans say insulation and they sort of put a little insulation in. Well, in this case, the contractor had some real responsibility to make sure all of their subcontractors got it right. So it's really a management of getting it up and down. I think that as more and more of these get built and you have better specifications surrounding this, and there's, you talked about training and what things people need to know to do this. As people know more about it and it becomes more routine, then you probably can look at other procurement paths. Mm-hmm. But right now what we have found is that this is the easiest. If you don't have that path, it can be done. Typically, it costs you more money.
Right. Now, I guess figuring back into the building envelope, I mean, when I think of net zero buildings, I think, obviously that is the orientation of the building, the, construction of the envelope. We're really kind of getting back to the, being reasonable about it. I mean, a lot, I guess, at least in my mind, I see a lot of architects that might like to make a statement or like to be fancy about it, and you really have to get down to function more than that. So it's, I guess, I kind of, would you agree to the fact that not only do engineers need to not do what they've been doing to attain, energy savings, but architects also have to look at the building envelope and improve upon that because they can't use what they've always used in the past.
Well, absolutely, and that kind of goes back to looking at the historical architecture. 100 years ago, architects had to do certain things because they didn't have electric lights and they didn't have cooling systems, right? And it's going back and thinking about that. But, the other part of it is that people tend to spend money on things that they want to spend money on. And so the architect wants to do, some nice finishes. They want certain looks, certain feel, and they're willing to spend money on that, where the engineer typically has to struggle to get money to put in more efficient equipment. And some of it is just being able to mesh those dollars together. If that makes sense. Again, that's part of this holistic thinking, that they understand the consequences. But all buildings have something in them that didn't have to be cost effective. Maybe a lot of wood trim, or maybe some expensive designer light fixtures. Those things are fine as long as people realize that extra money was spent, and that they chose to spend money on that versus maybe a daylight system that got them the same spectacular lighting, but also saved energy. One of my favorites is something like fountains, right? Mm-hmm. People love having fountains in front of their building. It's an architectural feature. People like to look at them, but they cost money and they use energy, right? So if you're going to do those kinds of things, that's okay, as long as you realize, that this isn't all about cost effectiveness. People don't spend money based on cost effectiveness. They use that as an excuse to get things out of projects. Mm-hmm. So they can usually use that money to buy something else. And that's one of the things about, a single procurement with fixed goals, that all of those things become balanced, that all of the goals are put out on the table up front, and it is the objective of that design team to meet all those goals, not just some of them, and then add energy efficiency after.
Now, I guess, ultimately getting to this goal of, okay, you've designed it, you've modeled it, you've constructed it, you've installed it, you've tested it. Now it comes time to actually monitor it, mm-hmm. analyzing the meters and things like that. I mean, what sort of different things are you doing with the metering data, to actually make sure that, it's actually attaining, what it set out to? I mean, obviously do you find that as a critical piece, or do you just, I mean, it's, you look at the utility bills and you say, okay, well, I'm net zero. Is there a lot more, heavy monitoring of it?
There can be. There doesn't have to be. I mean, even looking at utility bills gives you one data point a month, right? So that is still metering, and that's still monitoring your progress towards that goal. Typically, though, the more data you have, the better the chances of you picking up errors or things that are going wrong in that system and getting them corrected. And so, but you have to be able to use that data in a meaningful way. I see a lot of people collect a lot of data and spend a lot of money on data acquisition systems and metering and don't do anything with it. Well, at that point, there's very little value. There's another point that you kind of raised in there, too, in terms of how does the building perform according to an expectation or a design expectation or a goal set up front. What we have found is that a lot of people use energy models either for code compliance, maybe they use it for an initial conceptual to get them on track with energy efficiency, and they don't follow that energy model with the design of the building. And then they start publishing data about the building, and they say, oh, well, here's what our design model said the building was going to do. But that model, by the time construction is done, may not look anything like the original building. And then data starts coming in, and the two obviously aren't going to match. Okay? I mean, I've even seen people try to use models, different size buildings, all kinds of things. But you got to spend the money to make sure that prediction in that model is current with the design, that it follows the plans. We call it as-built models. Mm-hmm. If you do that, and then you operate the building according to that model, typically we find that they can get within about 10%.
Wow.
But it's there's some diligence that goes with that. The other part, and something that we've done, is we took those daily energy targets off of our model as built, and we actually compare it with our daily energy totals to see, on a daily basis, are we on track or not? And in some cases, you always find things like something in the controls where a pump was running, all the time, or, maybe some light sensors weren't calibrated properly, which is common, and so the lights are on all the time. You do have to commission the building and get it to meet the design intent. Otherwise, the two are not going to match, and you can't have an expectation that the two are going to match.
Right. All right, so if somebody wanted to learn more about how to design net zero buildings, or get more information just on the research that you've done, where are some places that they could do that?
So probably the easiest is do a search engine and look up zero energy buildings or NZEB. Quite often pulls up our work as well as other people's work. We've talked a little bit about NREL's new building, the research support facility, and how that was procured. You can find information about that at NREL. That's nrel.gov/RSF. You can get the procurement. You can get all kinds of photos and information about the building. Although I would warn people that that was designed for that application. I've heard of people trying to take that plan and say, and we talked earlier about say, I'm going to take that building because it works there, and I'm going to plunk it down in a very different climate. Mm-hmm. And that's some things will work. Like the plug load strategies will work. In that case. There's also a bunch of information and fact sheets on commercialbuildings.energy.gov, which is the commercial buildings program for the U.S. Department of Energy. And again, there's resources there. You can do searches on things like plug loads, daylighting, and get some of the different components. There's a lot of information that was just released on things like LED parking lot lights, LED parking garage lights, some newer technologies, and you asked about technologies earlier, that because of their directional nature and ability to turn on and off quickly, those kinds of technologies quickly are finding their way into these low-energy buildings.
Excellent. If somebody wanted to ask you a question, what would be the best way to get a hold of you?
So part of it is some of my bandwidth. If you go to that commercialbuildings.energy.gov, at the bottom there's a webmaster link, and questions can be asked there. Some of those get routed to me specifically. Others get answered directly by the webmaster. They will all get answered in a good technical fashion, probably at a quicker bandwidth than I will readily do it.
Understood. Well, Paul, I really appreciate you spending some time with us, talk about net zero or low energy buildings. Just appreciate all the information. I think it's really good stuff, and I hope we can have many more examples of these type of buildings in the future. Sure,
and be willing to tell us and others those stories. As people do these things. There is a website, buildingdata.energy.gov, and you can actually enter case studies and your buildings onto them. And people can look at that energy performance, and other people can learn, because that's one of the ways that we're going to get this market transformation, is that people see that other people have taken the risk, and that every additional person that takes the risk is less risk for the next person.
Excellent. And listeners can not worry about the jotting down all the URLs. I will get those and post them on the show notes on the website. So, again, thank you, Paul, for your time. I really appreciate it.
Okay, you're welcome.
All right, and we're back. Thanks again to Paul for taking some time out of his schedule to talk with us about the net zero energy buildings. I think it's fascinating. It's always been a great topic of mine. I mean, how you can actually minimize the impact in the environment. Whether or not you believe in global warming or you think the green movement is a bunch of smoke and mirrors. I think undeniably we should be good stewards of the environment that we have. We should leave the earth better than we found it, and I think that going in that direction, using less energy, being smarter about our designs, thinking about it a little bit more. I think we got the heating and cooling thing down. Now let's try to just kick it up a notch, take it up to the next level, and be able to be more inventive about the things that we do in engineering. So I appreciate Paul's words of wisdom there. Also, this again was a listener request. If you have a request that you'd like to have, just email me at matt@buildingx.co. Again, thanks to Michael for suggesting this net zero energy buildings. Hopefully it was all that he had hoped for. So thank you again for that feedback. Also, another word, another note, I'd like to do a special shout out to Kevin Rogers. Kevin Rogers is has left some feedback for me on iTunes, and if you've listened to some of the earlier episodes, I was groveling a little bit for some iTunes feedback. Really, it helps everybody. Personally, it helps me in the rankings as far as being found. If somebody, if you like the show, just give some feedback. I'd really appreciate that. And obviously, Kevin is the first one to take me up on that offer, so very special kudos to you, Kevin. Thank you very much from the bottom of my heart. Otherwise, again, you have full access to your host here, Matt at buildingx.co. If you'd like to sign up for a newsletter and kind of give some of the inside scoop, you can always go to buildingx.co, sign up for the newsletter there. I publish that about once a month, and I tend to give a little bit of tips and tricks, or certain, it's relatively short, but certain links that I find during the month, and I'll share those to the few, the proud, the newsletter subscribers. So, otherwise, if you like the show, please pass it on. If you want if you can give me some feedback, you know where I'm at. And other than that, I appreciate each and every one of you listening, tuning in week by week. And with that, I think I will wrap this up. Thanks for your time, and remember, know what you build. and share what you know.